This video, I'm trying out this new YouTube quiz feature that you should be able to see near the description of the video. I'll put something like this in the corner to indicate that you should answer the next question. And I'll give it a few seconds for you to answer. It might end up being like weird or clunky, but it seemed kind of cool and I wanted to at least try it and see. So to start off this video, pop quiz. What's the answer to this math problem? You might have seen questions like this on social media and thought, wow, what an easy math problem. And then checked the comments and were mortified at the discussions happening. How is there so much discourse over an elementary school math problem? Why are these math problems so confusing to people? At a glance, the concept that's tripping people up here is the order of operations. A lot of people remember this, but clearly not everyone. So the order of operations defines the order in which a math problem should be solved. In America, I learned PEMDAS as an acronym for remembering the order of operations, as parentheses, exponents, then multiplication and division, which were grouped together, and then addition and subtraction, which were also grouped together. Anything within the parentheses or brackets should be solved first, starting with the innermost brackets, and then any exponent should be solved, and then multiplication and division can be solved from left to right at the same time, and then finally addition and subtraction can be solved the same way. With these fundamental math rules, the equation from before can be solved somewhat easily. But that's not the real issue with this problem, or any problem like it. The real issue is that they're just poorly written equations that are meant to confuse you. Let's do another quiz question. What am I supposed to divide by here? 2 or 2 times 2 plus 1? Technically, you divide by 2 and then multiply by the 2 plus 1. And we can even verify it on a few calculators like the Windows calculator, the Google calculator, and then my TI 30XS from high school. And we all get the same answer, 9. If I was going to write this equation, I would use an extra multiplication sign or another set of parentheses to make it as clear as possible so that no one could misinterpret. But that does bring up another question. How do all of these calculators know how to do it correctly? Humans read and write equations like this: number, operator, and then number. We're taught this at a super young age, and we don't even really think twice about it. This method of writing equation is called infix notation, because the operator, the mathematical symbol like plus, minus, multiplication, or division, is fixed in between the two numbers. While computers could handle math problems with infix notation, it isn't very efficient. Lucky for us, there's a way that we can write equations, which is much easier for computers, but a little less intuitive for humans. It's called postfix notation, or reverse Polish notation. In postfix notation, we write the operator after the two numbers. Using this rule, the computer knows that if it ever reads an operator, the previous two numbers will be used in the calculation. And even luckier for us, famous computer scientist Edgar Dijkstra, famous for his pathfinding algorithm, also designed an algorithm that turns infix notation into postfix notation, called the shunting yard algorithm, based on railroad shunting yards. This algorithm is able to account for the order of operations to perfectly translate infix notation into a form that computers can solve really easily. The key to both of the shunting yard algorithm and then solving the equations in postfix notation is the stack data structure. Stacks are collections of values that only let you add and take away values from one end, like a stack of pancakes. If you want more, you add them to the top, and if you want less, then you take them off the top. You could pull a pancake from the middle or the bottom, but then your stack falls over and my analogy falls apart, so just run with me here. The shunting Yarg algorithm utilizes two stacks, one for the output and then one for the operators. While reading through an equation in infix notation, the numbers can be added to the output stack, while operators are added to the operator stack. If we get to an operator while there are already some on the stack, the algorithm decides based on order of operations if the current operator should get popped off and then put onto the output stack, or if it should stay there and then the new operator should be stacked on top. We get to the end of the equation and there are still items on the operator stack, we just push the rest to the top of the output stack, and we're done. When solving the equation that's now in postfix notation, we can read through each value, adding each number to the new stack. Then when we get to an operator, we can pop the last two numbers off the stack, and then run a calculation using the operator we encountered, and then push the results back onto the stack. Eventually, if we did everything right, we'll end up with one value that has gone through all of the calculations in order to get the final answer. Put together my own version of these two algorithms, on the GBA of course, to build a calculator. And I did it in 2 steps. The first step was to build a text-based version, just to sort of test the logic and then make sure that the algorithms were working correctly. This version does not allow any input from the user, but as the developer, I can write the equations out in the code and then have it print out that same equation and then the answer it returns. During this process, I realized I was not handling negative values properly because they use the same symbol as subtraction. So I had to fix that up, but it works like a charm now. The next version I made was for users and is loosely based on the iPhone calculator. Nothing super fancy, but you can type out characters and then press the equal sign and it will print out the answer. And you can also see the previous few equations that you typed as well. We'll do one final quiz question to see if the GBA and you can solve this equation. This project was a lot more about the theory behind computer calculations, but it was still really cool to work on and complete. If you want to check out the code, I'll put a link to the GitHub repository in the description. And if you just want to see the finished products of the GBA files, I'll put a link to the final release page as well. Something about using a simple data structure like a stack to translate a human-readable equation into a program-readable format that can be solved using another stack was really interesting to me. This video is just a summary of the basics of the shunting Yarg algorithm, but if that was interesting, I recommend this video by JavidX9. We've talked about a few of his videos already, but honestly, he makes really cool videos on computer science topics and game development topics and does a great job with making them easy to understand. If you liked this video and you want to see more computer science videos or GBA projects, subscribe. And honestly, let me know what you think of this quiz thing. I literally haven't seen it anywhere else on any other YouTube channel, but I imagine it's still going to be a little clunky because it's new, but your feedback is appreciated. All right, thanks for watching.